This tape describes how composite video is changed, recorded, and played back on the SL-2710 videotape recorder. This tape will follow the signal chains, not only showing how each stage treats the signal, but how other stages interact with it. In this way, even a minor disturbance in your tape's video path may be detected by comparing waveforms to the working SL-2710 described in this section. In addition, electrical adjustments are pointed out as the stage is explained, so the importance of each adjustment to the overall operation is realized. Audio tape recorders can store up to 20 kilohertz on magnetic tape. However, the same method cannot record frequencies to 5 megahertz, the bandwidth of composite video. Further analysis of composite video and the recording technique brought a method to solve this problem.
A 1-volt video signal may be changed to FM, occupying a smaller frequency range that may be recorded using a rotating head helical scanning system. This conversion is done in an FM modulator, which lets 0 volts DC equal 3.5 megahertz and 1 volt DC equal 5 megahertz. To avoid the color in the video signal from interfering with the new FM luminance signal, the chroma must be down-converted from the normal 3.58 megahertz to 688 kilohertz. This is the basic concept behind the video processing in home video cassette recorders.
An overall description of the video recording and playback sequence is followed by a detailed circuit explanation involving waveforms at key points and electrical adjustments for a clearer understanding for troubleshooting. The successful recording and playback of composite video involves a sequence of processing stages for both the luminance and chroma parts of video.
The block diagram of the record section shows the comb filter separating the video signal for individual luminance and chroma processing. The luminance high frequencies are boosted afterwards in the pre-emphasis stage. This is done to overcome tape noise. Emphasized luminance is then FM modulated to produce an RF envelope, which is current amplified in IC 501 before being applied to the recording heads. Chroma, which had been separated from the luminance at the comb filter, is mixed with 4.27 megahertz at the converter to bring the chroma down to a new 688 kilohertz base frequency. It is then mixed with the luminance before being amplified for recording onto the 1/2-inch videotape. The playback block shows the RF signal taken from the videotape and simultaneously applied to the upper luminance processing blocks and the lower chroma processing blocks. The demodulator in the upper chain changes the RF envelope to luminance, and then, because the high-frequency part of this signal was boosted in record, a de-emphasis stage returns the signal to produce a flat frequency response. A dropout compensator circuit monitors the RF signal. If a segment of the RF signal is missing, the last active horizontal line of luminance is inserted, so no evidence of dropout is seen. The noise canceller samples just the high-frequency luminance signal. It then inverts it and adds the inverted signal to the main luminance signal, thereby canceling the noise. The jog circuit is used to correct for vertical and horizontal instability when the video heads cannot scan the entire video track correctly. This occurs during cue, review, ×2, pause, and slow motion. The finished video leaves the Betamax at the output terminal. Chroma is handled as shown in the bottom playback block diagram. The low-frequency chroma at the left is mixed with 4.27 MHz in the converter to restore the original 3.58 MHz chroma. The comb filter is used to remove the crosstalk or interference picked up from the previous track, and the ACK circuit senses the presence of color by using the burst in the video signal. It places the ACK signal on the chroma signal. These signals are then applied to the YC mixer, where it is added to luminance to produce the composite video.
Playback, not record, is often used for troubleshooting, so this playback strategy will be demonstrated first using color bars from the Sony alignment tape as a source of signal. A video track from the KR5-1M alignment tape contains the AM color signal, the FM luminance signal, and the beta hi-fi signals. At the end of section 1 in the circuit description book are troubleshooting block diagrams for various modes of operation. These diagrams contain the key input and output levels for each circuit stage. The playback signal sensed by the head is amplified by the head amplifier and RF amplifier blocks to produce an RF output, shown here to be 0.18 volts peak to peak.
The circuits in these blocks are found on the schematic of the HA5 board. The signals on the video track are picked up by 3 video heads and are connected to this board through the CN151 connector located in the lower left-hand corner. The signals are then applied to independent preamplifiers at IC501 pins 1, 14, and 19. These preamplifiers are controlled by switch inputs from pins 20 and 21. Pin 21 is always grounded, but pin 20 is only grounded in pause to turn on the A' head amp, which is used in still. The preamplifier's output at pins 16, 17, and 27 to IC502. IC502 contains additional preamplifiers. These bring the video head signal out of the noise so it may be selected for the playback signal chain. During normal playback, in-phase RF switching pulses appears at pins 19 and 20. These signals select the A and B head signals. Pin 19 gets the main RF switching pulse from buffer Q19 on the main VI2 board. Pin 20 also gets the RF switching pulse, but from Q24 on the main board. During pause, the signal to pin 20, labeled RF switching pulse V, is grounded out on the VI2 board. IC 502 then selects the A prime and the A heads instead of the A and B heads for the RF output. Also during pause, the A prime preamp in IC 501 is turned on with a low at pin 20.
Amplified RF signals leave IC 502 pin 17 sequentially. Connect the scope to CN153 pins 3 and 1. This 1 volt output is now observable and shown compared to the lower RF switching pulse to identify the head outputs. Head B is scanning the tape when the RF switching pulse is high. Although this is how the unit ideally works, as the unit is used, unequal outputs from the heads will result due to wear. This is compensated for by the gain and dump adjustments to the right of IC 502 for each video head. The B2 sweep section of the alignment tape is used to do this while monitoring the exposed checker pins at CN153 pins 3 and 1. Adjust RV505, the frequency dump control, for the flattest response from the A head. Then adjust RV501 for the flattest response for the B head. RV502 gain control is then adjusted so that B head is equal to A.
From IC 502, Q504 and Q508 take the A and A prime head signal to produce the beta hi-fi signals. Q503 and Q505 do the same at the B head's output. These buffers take the RF signal from the 3 video heads and introduce them to 4 bandpass filters. This produces the 4 signals for the beta hi-fi carriers. The A prime head output, although not used for audio output in pause, is needed to maintain the beta hi-fi mode during pause.